All right, let's jump straight into this explainer. Right now, the booming AI industry is triggering this massive, completely invisible domino effect across the entire global memory supply chain. It's a wildly fascinating phenomenon starting in the world's biggest tech hubs. But here's the thing, it's about to hit your wallet in ways literally nobody saw coming just a couple of years ago. We're looking at a total reshaping of how everyday electronics are made, priced, and sold, all because modern computing is just impossibly hungry right now.
So, to really wrap our heads around this, we need to pull the invisible thread that connects a suddenly expensive budget smartphone in Africa or South Asia straight back to the massive data centers over in Silicon Valley. I mean, why on earth would the price of an entry-level phone in 2026 be driven by the latest AI chatbot? Well, it all comes down to the actual silicon, the chips being printed in the factories right this very second. It's the ultimate story of supply and demand, but dialed up to a scale we've rarely ever seen in consumer tech.
Section 1. The AI memory squeeze. Let's see where this all starts.
Okay, so the core of the problem really comes down to just raw compute and data volume. Look at this comparison. Your standard conversational AI chatbot, it uses around 10,000 tokens to spit out an answer. You type a prompt, you get a response, you're done. But this new agentic AI we keep hearing about operates in a completely different universe. These autonomous agents are running continuously in the background. They're coding, planning, debugging, and doing all of this over hours or even days. Because they literally do not stop, they chew through over 1 million tokens per task. The compute load isn't just a quick sprint anymore, it's a brutal, never-ending marathon that pushes hardware to the absolute breaking point.
Now, to process all those millions of tokens without the whole system just freezing up, these giant data centers desperately need high bandwidth memory, or HBM. Think of HBM like a massive, high-speed superhighway. Standard RAM is kind of like a 2-lane country road, which, is totally fine for opening a spreadsheet or browsing the web. But AI processors think so incredibly fast that they need a 12-lane Autobahn just to feed them data. Without HBM, the most advanced AI chips in the world literally just sit there twiddling their thumbs, starved for data, bottlenecking the whole operation.
Because of this frantic demand, manufacturing is changing overnight. Silicon wafer space on a factory floor is strictly finite. You can't just snap your fingers and build a new fab. It takes years and tens of billions of dollars. Historically, HBM was this super niche product, taking up, maybe 2% of global wafer capacity? But look at this projection. By the end of 2026, it's expected to swallow up a massive 20% of total global capacity. That is a completely unprecedented land grab on the factory floor.
Let's just quickly trace these dominoes so the big picture is crystal clear. 1. Agentic AI demands millions of tokens. 2. Data centers panic and hoard all the HBM they can get. 3. Because the factories are busy printing HBM, standard memory gets totally squeezed off the production lines. And boom, 4. Standard memory becomes scarce and consumer electronics prices shoot through the roof.
Which brings us to Section 2, Consumer Electronics Price Shock. So the real kicker here is that this silicon shortage doesn't just stay locked away in some enterprise cloud, it comes straight for your living room. Because the fabs are printing highly profitable HBM for the AI giants, production of standard DDR and LPDDR memory is falling off a cliff. And guys, that's the exact RAM inside your laptop, your smart TV, your everyday phone. Supply shrinks, warehouses empty out, and suddenly any hardware manufacturer who needs RAM has to pay an absolute premium to get it. This isn't just an inconvenience, it has profound real-world consequences today. We're seeing profit margins for everyday electronics getting totally crushed. But what's really alarming is the direct impact on sub-$100 smartphones. Why is that such a big deal? Because in emerging markets across Africa and South Asia, those budget phones are literally the only lifeline people have for internet access, banking, and education. If it costs too much to build them, they just stop getting made, or they get priced out of reach. So crazy as it sounds, the AI race in Silicon Valley is actively threatening basic digital access for millions of people globally. Moving up the chain, we have Section 3, the hyperscaler CapEx crisis. Let's look at the tech titans, the hyperscalers like Microsoft and Google. Even with their endlessly deep pockets, they are feeling the burn. Microsoft's just announced they expect their capital expenditure for 2026 to hit a staggering $190 billion. I mean, let that number really sink in for a second. That is an absurd amount of money for 1 year of infrastructure. It's so high that Wall Street analysts are actually starting to sweat, asking these executives, hey, when are we actually going to see a return on this investment? When you dissect that $190 billion, this is where it gets wild. A massive $25 billion slice of that increase isn't even for new buildings or cooling systems. It's directly caused by the surging prices of memory and storage components. The CPUs and GPUs get all the flashy headlines, sure, but the memory chips inside those servers are demanding a massive premium right now, and it's blowing infrastructure budgets out of the water. And look how different companies are handling it. Microsoft is kind of just gritting its teeth and absorbing these insane costs to keep their market share. But Alibaba Cloud? They straight up hikes their prices by up to 34% for compute, storage, and software services. They pointed right at hardware costs and AI demand and said, we're passing this on to you. So if you're wondering why your company's cloud hosting bill is suddenly creeping up, yeah, this is exactly why.
All right, on to Section 4, hardware workarounds and counterfeits.
When legitimate supply dries up, the industry gets incredibly creative. Take Intel, for example. They recently showed off their new Crescent Island AI GPU. But instead of fighting in the trenches for ultra-scarce HBM chips, they completely pivoted. They designed this GPU to use a whopping 480 gigabytes of standard LPDDR5X memory. They literally rewired their architecture just to avoid the HBM bottleneck altogether. It just goes to show how engineers are being forced to rethink the very basics of hardware design right now.
But of course, where there's a shortage, the black market is never far behind. Tom's Hardware recently reported a massive flood of highly sophisticated counterfeit DRAM hitting Chinese marketplaces. Scammers are taking absolute garbage, low-grade memory, slapping it onto identical circuit boards, and gluing a premium heat spreader on top to make fake G-Skill and V-Color DDR5 modules. It looks totally real right up until you plug it into your motherboard and it completely fails. The scammers are having a field day with these inflated prices.
So how do we fix this? Section 5, the $500 billion solution. The fix comes with a price tag that is honestly hard to even visualize. $500 billion. Samsung and SK Hynix have committed $500 billion to build more RAM fabrication capacity. It's one of the largest coordinated private infrastructure plays in modern history, and its sole purpose is just to make sure the world doesn't physically run out of the memory we need to keep the lights on. Beyond those megafobs, you've got Alphabet raising another $80 billion just for their own AI infrastructure. Plus, there is this massive trend of localized semiconductor investment right now. Countries and companies realize they can't rely on just one or two factories halfway across the world anymore. The entire industry is frantically trying to pour concrete and build its way out of this shortage before technological progress grinds to a halt. So, as we wrap up this explainer, I want to leave you with a question to chew on. Will these unprecedented, massive investments actually stabilize the supply chain and lower our electronics bills? Or is the new AI economy's hunger for memory literally bottomless? We're building factories as fast as humanly possible, but with AI models getting exponentially bigger every few months, we might just be staring at the new normal. Thanks so much for diving into this with me. See you next time.